First of all, we have to know what a bridge is. A bridge is a link or connection between two objects, usually places either side of an obstacle, such as a river, channels, or estuary. Across gulfs and rivers between people and countries, bridge breaks down separation and fosters connectedness. Some of the benefits of the bridge are obvious. Supplies of food and traded goods can get across an obstacle or through difficult terrain in a shorter time. There are some type of bridges, as we know. The beam bridge. This is the earliest and simplest kind of bridge, a fallen tree lying over a stream, perhaps, or a log loaded across a narrow channel. We still come across this when walking in the hills, and there is no way of dating the first time some Hamden straining or stabilization such a beam are thereby became the world's first bridge engineer. All beams tend to sag between the piers and hug over the piers themselves. This results from the downward forces of the load and the upward forces at the pier supports. The greater span or the load, the greater the tendency towards sagging and hugging. To create beams that have the effect of being very deep but don't weigh much, ingenious 19th century bridge designers in the United States added supporting leadworks or a truss to the bridge beam. There are many stable variations of truss. The arch bridge. The arch is really a beam curved to form a semicircular shape, which is prevented from the stranger and spreading sideways by strong abutments at either end. One disadvantage of the arch is that it needs firm support from the sides. If there are no abutments or bank to build against, the arch will spread and collapse. The suspension bridge. A suspension bridge is one where the road deck is suspended from cables that are strung across the river, or wherever the obstacle happens to be. There is no support in the center of the span, and the deck hangs below the supports rather than the resting up and down. One example of the advantages of suspension bridge is the Tacoma Narrows Bridge, that unfortunately it displayed rather too much grace and flexibility, becoming known as galloping girder, from the wake-like motion of its deck even in light winds.
The Tacoma Narrows Bridge, spanning Puget Sound, was the third longest suspension bridge when it was dedicated in 1940. It soon gained the nickname Galloping Gertie because of its tendency to sway and twist in the wind. After only 4 months, the bridge tore itself apart in strong winds and tumbled into the Sound.
In the cable-stay version of the suspension bridge, the deck is hung from diagonal cables that exert a force towards the towers, as well as vertically. This makes the tension in the steel cables extremely high, and hence they are very stiff. In addition, the cable's flexibility stabilizes the towers from both sides. In summary, it looks like the fur has two faces, as far as bridges are concerned. The mass-produced bridges built to standardized designs using cheap and readily available materials like concrete and steel. Functionality is the keyword, where quantity is concerned, and quantity is the keyword when a typical stretch of new motorway can require building and new bridges every mile or so. We can expect see dull but dependable main bridge across our roads a railway for a good while yet. The one-off iconic bridge, such as those commissioned for millennium projects throughout the world. Many cities like the idea of building an innovative bridge to symbolize their modern outlook, and their opens to certain ideas of the future. These one-off bridges are often designed as such for their form as for their function, and public competition and frequently held to choose a suitable, impressive-looking addition to the city skyline. Eco-friendly planners away from the city also like the idea of nature being complemented by high-tech, low-impact bridge designs. But the technology and the progress of our times have brought us to improve the bridges and has increasingly made the creative of the designers, architects, engineers to another level. As an example, we have the chosen bridge, Moises Bridge. Creative pedestrian bridge near Fort the River in Halstern, Netherlands divides the water like Moses and allows people to safely cross to the other sides. It's designed by Rowe and Ed architects. In unique tech-inspired sunken bridge was constructed out of extremely durable Akoya wood. A series of moats and fortresses were built over the West Brabant waterline region of Netherlands during the 7th century in order to provide protection from invasion by France and Spain. Fort the River was surrounded with a shallow moat that was too deep to march across and too shallow for boats. In turn, the earthen fort has remained protected until now. From afar, the Moses Bridge is invisible to the eye. The flow of the moat appears continuous as the water level remains at the same level, reflecting the surrounding foliage. As visitors approach to the fort, the bridge appears as a break in the water, which is sloping walls containing it. First place is at ground level, but it drops to crawl deeper water. To achieve this, the structure is anchored the ground by steel piles. The entire structure is covered with Akoya wood and materials specially treated waterproof the bridge and can resist erosion by the stern, protecting it from fungus and increasing its durability. It was recently recognized by the Dutch Association of Architects as the best structure for 2011. Also is among the finalists for the Dutch Design Awards 2011 too. It's not a surprise all the advantage that the bridge has, such as communication between two sides, the principle that is invisible to your eyes, that is not perturbing the context, and also integrates to the nature. But bad news are always around, and we don't doubt about the great bridge it is. But as we know, Netherlands is underwater, and every year the water level of the ocean increases. So we're wondering if someday the bridge will submerge.